Today we're going to learn how to figure out which of our factoring methods or which combination we need to use to solve a problem. So if you look at your page 112, I'm going to be going through that. You don't want to be writing on the flowchart, but I'm going to write on it to show how we're going to use it to help us solve problems. So first, let's look at 12a squared b squared minus 3ab. The first thing I need to do is see, does it have a GCF? In this case, I do. If I look at 12 and 3, there is something that goes into 12 and into 3, and that would be 3. So I'm going to divide both of my terms by 3. And I also want to check my variables. Look how I have an a in both. That means that I can also take out an a as part of my GCF. Likewise, there's a b in both, so I can take out a b in both of my terms. Once I've divided, then I have what's left. So 12 divided by 3 is 4, a squared over a is a, b squared over b is b, minus 3 over 3 is 1, and a over a, b over b cancel. Then I've factored it out, so I say, how many terms do I have? I have 2 terms. So I see, do I have subtraction? Yes. Do I have perfect squares, which includes even exponents? The answer is no. So I'm done, and I don't have to factor anymore. So my solution would be 3ab times 4ab minus 1, but for today, all we need is that we need to factor out a GCF. So that's my answer for the first question. Looking at the second question, I have 4x squared minus 9. I always start with, does it have a GCF? Is there anything that goes into 4 and into 9? No. Is there the same variable in both? No. So I go to, how many terms does it have? Well, it has 2 terms. So then I want to check and see, do I have subtraction? Yes. Do I have perfect squares and even exponents? Yes. So I would factor it as a difference of squares. So my answer for number 2 is difference of squares, or DOS. Tomorrow we'll practice actually going through and factoring all these. My next one, x squared minus 16 y squared. Do I have a GCF? I only have 1 and 16 for my numbers, so that's not going to work, and I don't have the same variable in both, so I would say no. How many terms do I have? 2. Do I have subtraction? Yes. Do I have perfect squares and even exponents? Yes. So I would factor it as a difference of squares. And if you've been practicing in class, then you know how to factor something as a difference of squares. The hard part now is knowing that I need to do a difference of squares. Let's look at another one. X squared minus 9x plus 20. Always check for a GCF. I don't have any numbers that go into 1, 9, and 20. I don't have a variable in all of them, so I say no. And I say, how many terms do I have? 3. Is a 1? Yes. So that means I would use the x factor. And that's it. If it seems easy, it's because it is. If I use my flowchart, these can be very simple. And feel free to replay one of these if you aren't following. Looking at the next one. First, I need to look for a GCF. Is there anything that goes into 9, into 12, and into 4? It has to go into all 3. No. Do I have the same variable in all of them? No. So that takes me to No, it doesn't have a GCF, so I say how many terms do I have? 1, 2, 3 terms. And then I need to ask, is A 1? I don't think so. I see a 9 out there, so I would need to factor this using the X box. Next one we get a little bit trickier. Just a little bit. So here I need to be careful. Do I have a GCF? Yes. If I look, both of these have an x, and specifically, they both have an x squared. I take my lowest exponent, which is the 2. So I need to divide both of my terms by x squared, and that would leave me with 8x minus 1. So then I say, how many terms do I have? 2. Do I have subtraction? Yes. Do I have perfect squares? No. 8 is not a perfect square, so I would be done, and all I've had to do in this problem is take out a GCF. What about x squared plus 49? I definitely don't have a GCF. I have 2 terms, but I don't have subtraction. So that means my answer would be prime. I didn't have a GCF, and it's not difference of squares. So the only thing I can say is that it's prime. Just like there's nothing besides 1 that goes into 3. We would say it is a prime number. So we can have prime expressions. Okay, looking at 16x cubed plus 16x squared plus 3x. Now, none of those numbers have anything in common, but they all have an x attached, so I can take out a GCF of x. Once I do that, I would have 16x squared plus 16x plus 3. So I had a GCF. I have 3 terms, and A is not 1, so I would want to try it with Xbox. Now, this doesn't guarantee that there's something that would work with Xbox, but that is what I would try. Why don't you try doing x squared minus 9x plus 18 and 6x squared plus 13x plus 6. Finish the front of that page. You should get, after thinking about it, so press pause if you haven't answered this, you should get that the first one is the x factor and the second one is the x box. Neither of them have a GCF. Going to the back, 2x squared plus 3x minus 2. I don't have a GCF. I have 3 terms. A is not 1, so I would try factoring this with the x box. You try writing down your answer for 5x squared minus 22x minus 15. Press pause. Does it have a GCF? No. How many terms does it have? 3. Is A 1? No. So this would also be X box. 3x cubed plus 9x squared minus 12x. Well, when I'm writing that out, I'm seeing that all of those are divisible by 3. So I already know I definitely have a GCF, and they all also have an x. So I'm going to take out a 3x and see what I'm left with. So that would be x squared plus 3x minus 4. So now how many terms do I have? 3. When I look inside my parentheses, is A 1? Yes. So I would try doing the x factor. So this is one where I would try doing a GCF and x factor. I think you can do the next two ones on your own. X squared plus 3x minus 28, x squared minus 8x plus 16. You can do those two. I'm going to skip to 8x squared minus 6x minus 2. Now, once again, I'm writing those down, and I'm sensing that all of those are divisible by 2. So I do have a GCF. Yes. When I take that out, I have 4x squared minus 3x minus 1. So I factored it out. How many terms do I have left? 3. Is A 1? No. So I would try doing this as GCF and Xbox. Once again, this doesn't mean it necessarily works. It just means that that is what I'm going to try to do after I've taken out my GCF. And one more. X to the 4th minus 11x cubed plus 24x squared. Once again, I'm just making an observation. When I'm writing that out, I feel like I wrote x a lot. And specifically, my lowest exponent of x is 2 squared. So I'm going to divide each term by x squared. And that would leave me with x squared minus 11x plus 24. So I did have a GCF. Yes, I factored it out. Now when I look at what's left, I have 3 terms. I need to see if A is 1. Inside my parentheses, A is 1, so I would try doing it with the x factor. So to summarize, it had a GCF, and then I would check to see if I can do it with the x factor, just what's left in my parentheses. Okay, so feel free to go back and look at any of those examples that you need, and make sure that all of those problems you've listed, what your method of factoring is going to be. Is it GCF, x factor, xbox, difference of squares? So all of that should be complete by tomorrow for full credit. Have a good night.